Now we are going to understand the purpose of number system. To understand this number system, we'll have to deal with the data representation, how the data works, and the two ways of data conversion, which is the division method and subtraction method. So let's go one at a time. First, let's understand what is number system and how does it work. So I'm just going to put here together number system. Now, to understand this, I'm just going to have a pictorial representation. So this is the human and this is the machine, and in this case let's take a computer. I'm using the word machine because it could be a laptop, desktop, phone, anything. So we are going to deal with this. Now we are working in different ways. When a human sends data to the computer, it's sent in a very specific way that's called decimal number system. And when the computer it takes it and processes in a different manner, which is called binary number system. And after the processing is done by the computer, the information is sent back to human so that it can be understood in decimal. So to put it together, the human will send information to computer in decimal format, and this is processed in binary and sent back to the human in decimal. So the question arises here, what is decimal? What is binary? And then to improve the processing speed, now we have got one more number system which is called hexadecimal. So we are going to look into the three number systems which is called decimal, binary and hexadecimal. We call them a number system because they are all made out of digits, and digits are processed in different formats. So let's go. Decimal. As the word says decimal, let's look at the characteristics of decimal. It has got 10 characters. I'm using the word characters because if we move on, in hexadecimal, we have got the combination of digits and alphabets. So characters keeps it same. So 10 characters. What are the characters? They are 0 to 9. So these are the 10 characters, 0 to 9, and that's why it's called as base 10. So this is all about decimal. Now let's look at the next one, which is the binary. Now for binary, as the word says, binary, there are only two characters. What are the two characters? The two characters are 0 and 1, and that's why it's called as base 2. And the third also, which we are going to use because computers are using hexadecimal, let's talk about it simultaneously. Hexadecimal. Look at the word, the way it's called. Hexa is 6 and decimal 10. So it's 16. So 16 characters. So how do we get the 16 characters? Because we have got only 0 to 9 digits. So 0 to 9 makes it 10. And then you have got 10, which is represented by capital A, 11, 12, 13, 14, and 15. So these are 10, 11, 12, 13, 14, 15, and 16. So A, B, C, D, E, and F. These are all represented in alphabets A to F in uppercase. So if you talk about the 16 characters, it means we have got 0 to 9 and A to F. Since it's 16, the base is 16 in this case. So this is the basic understanding of the number system. Now we are going to deal in the conversion, and let's see how it works. Let's continue and understand the first two, the decimal and the binary conversions, how they are converted from one number system to the other. So to understand this, we need to learn something about the storage unit of computer. So the data is stored in form of bytes, or in another word you could say byte is the measuring unit of data. Now let's elaborate and understand what's a byte. So I'm going to make a little diagrammatic representation. We need 8 boxes. 1, 2, 3, 4, 5, 6, 7, and 8. So these are the 8 little boxes. So one little box is called as one bit, B-I-T. And when we have got the 8 bits together, it's called as one byte. So basically, 8 bits are equal to 1 byte, and then it goes on. So moving on a little bit further, if we have got 2 raised to power 10 bytes, which is equal to 1024 bytes, it gives us 1 kilobyte, and so on. This relation then keeps going, and we'll study about these further. For now, let's focus and see how the decimal is converted into these binary bits and then back to the decimal. Now let's use the first method, that's called as the division method. And we are going to convert a given decimal number into binary. Let's take an example. Any number is fine, and we'll take, let's say, number 25. So how do we do that? Let's look at the process first. So what you need to do is put the number 25 over here in the center, divide it continuously by 2, and keep collecting the remainder. So if we divide 25 by 2, it goes 12 times, and the remainder is 1. Let's go next. 2 6 are 12, remainder is 0. 2 3s are 6, remainder is 0. 2 1s are 2, remainder is 1. And then if you divide this, it's 2 0 times gives you 0, and the remainder is 1. So you need to be careful. Start dividing the given decimal number by 2, collect all the remainders, which should be either 0 or 1, and divide it until you have reached the end point, which is 0. Now we need to collect all the remainders, which is from bottom to top. So let's write the remainders together, and it goes 1 1 0 0 1. So this is the binary number. How do you write together? So 25 is in decimal, so put it in the bracket. The base is 10, which is equal to, put the binary number here, and the base is 2. So this is the basic idea of the conversion. If you look at the storage, how does it get stored into the 1 byte? 1 byte means we have got the 8 little columns, 1 2 3 4 5 6 7 and 8. Start writing from the right hand side. So 1 goes here, 0 0 1 1. The remaining bits are going to be filled with 0. So this is the binary equivalent for the number 25 in decimal. That's how it's stored in the computer. So we'll do a few more examples to understand the conversion. Now that we have got this decimal converted into binary number, let's also try to convert it back and see if your answer is perfect or not. So what we're going to do is, we are going to convert the binary to decimal. And what's the process? We'll take the same binary number. So the binary number we are taking is 11001, and you need to find out what is the decimal. So let's see. When you're writing a decimal number, how do you write that? Let's put it together. Decimal, it starts from 10 to the power 0, 10 to the power 1, 2, 3, 4, and so on. The numbers are always written from right to left. This gives us 1, 10, 100, 1000, and 10,000. In the same manner, we have got the binary also. So let's put the binary together. So binary will also start from 2 to the power 0, 1, 2, 3, 4, and so on. And this is 1, 2, 4, 8, 16, and so on. Since we are dealing with the 8 bit, so I could put it together in one little row with the 8 columns together. 1, 2, 3, 4, 5, 6, 7, and 8. So this will be 1, 2, 4, 8, 16, 32, 64, and 128. This is going to be the maximum for the binary because we are dealing with the 8 bits or 1 byte. Let's take this number 11001, which is in binary, and convert it back into the decimal. So to continue, we are going to use the same process. So we are going to write the numbers starting from the right side, 1, 0, 0, 1, 1. Let's put the equivalent number with starting with 2 to the power 0, which means 1, 2, 4, 8, and 16. We do not have many more digits because it's going to be 0 for the 1 byte. So we can leave it as it is. Now, you need to multiply these together and add them. So basically it means 16 times 1 plus 8 times 1 plus 4 times 0 plus 2 times 0 plus 1 times 1, which is 16 plus 8 plus 0 plus 0 plus 1, and that's equal to 25 in decimal. Let's take an example as number 77, which is in decimal, and convert it into binary. For now, I'm putting a question mark because we don't know what is going to be the equivalent binary. Using the division method, which is the focus for now, let's get started. Divide the number continuously by 2 and collect all the remainders. 2 3s are 6 and 2 8s are 16 gives us the remainder 1. So I'm going to just keep collecting all the remainders, and remember the remainder can be only 0 and 1 while you divide any given number by 2. A simple mathematical rule. So 219 times is 38, so the remainder is 0 in this case. 2 9s are 18 and the remainder is 1. 2 4s are 8, remainder is 1. 2 times is 4, remainder is 0. 2 1s are 2, remainder is 0. And 2 times 0 is 0, so the remainder is 1. You need to continually divide until you get the 0 at the bottom, so it makes it clear. So in this case, the remainder is 1. Now that the division is complete, we need to collect all the digits bottom to top. So it becomes 1, 2 zeros, 2 ones, 0 and 1. This should be the equivalent in binary. So basically when we write the number 77, which was in decimal, is equal to 1001101, and in binary. You could also add the extra bits as 0 towards the left if you want to make it 1 byte. But it's generally understood that this is how it's going to work. Okay, to test, let's convert back this binary into decimal. So we are going to do the binary to decimal conversion. Let's take the same details from above so that we can check the answer as well. So the question here is, how do we convert this given binary into a decimal, and what's the answer? So for the answer as of now, I'll leave it with a question mark. So let's get started. We need to write the digits very carefully without missing any, and then we are going to multiply them with the place values of 2. So this is 2 to the power 0, which is 1, 2 to the power 1, which is 2, 2 to the power 2, 4, 3, gives you 8, 2 to the power 4 gives you 16, 2 to the power 5 gives you 32, and 2 to the power 6 which gives you 64. You can actually write these directly because with time you memorize them as well. And then the next step is you need to multiply them. So basically this is going to be multiplied by this, and then you're going to add it with the next, and the process continues. So let's get one by one. So it's going to be 64 times 1 plus, this is going to be 0, so I'm writing it 0 plus 0, and then 8 times 1 plus 4 times 1 plus 0 plus 1 times 1. So this gives us 64 plus 8, I'm skipping the zeros, plus 4 plus 1. So 64 and 4 is 68 plus 1 is 69 plus 8 is 77. So this 77 is in decimal which we started with. So I hope you understand how the decimal is converted to binary and how you could check the answer by converting the binary to decimal as well. We'll continue with few more examples to make sure that you do not forget how to do the mathematics. Decimal to binary. Let's take an example as number 196. Since it's base 10, so I'm going to write it with base 10. We do not know what is the binary equivalent, so a question mark and the number 2 as the base is 2. So let's use the division method again and collect the remainders. I hope by now you are expert and there's no calculators to be used over here because it's simple division by 2. So 2 9s are 18, and then we get 16, 2 8s are 16, and the remainder is 0. 2 4s are 8, then we get 18, and 2 9s are 18, so remainder is 0. 2 2s are 4, 2 4s are 8, the remainder is 1. This is simply now straightforward. 2 12 times, remainder is 0. 2 6 times, remainder is 0. 2 3 times, the remainder is 0. 2 1 time, the remainder is 1. 2 0, and the remainder is 1. We need to collect from bottom to top. So 1 1, 1 2 3 zeros, 1 2 3 zeros, 1 and 2 zeros. This is the binary equivalent for now. Let's use the reverse method, binary to decimal. It will help us to check the answer while getting more expertise with the conversion method, binary to decimal. So let's write the number 1 1 1 2 3 zeros, 1 2 zeros. Let's write the powers of 2 place values. So 2 to the power 0, we start from right moving on to the left. 2 to the power 0 is 1 2 4 8 16 32 64 and 128. This time we have got 128 because there is enough number of bits. So let's ignore the zeros and add them together. So it becomes 128 plus 64 plus 4, and that should give us the required number. So 8 and 4 is 12 and 4 is 16. So we get 6, carry 1, 6, 7, 8, 9 and then 1. So this is the decimal equivalent. And just for information, I'll put a remark over here. Decimal is also referred as Denary. I hope by now you are expert with decimal and binary conversions. We have seen how the division method works when we want to convert the denary to binary. So in this lesson we are going to see how the subtraction method can be used to convert the denary to binary. We need to understand that this whole process involves successive subtraction of powers of 2 until the value 0 is reached. Sounds a little difficult to understand. So let's do the practical conversion of a denary into binary to get the answer. So let's take an example. Let's say you have got a number 142 which is in denary, and we are going to use the subtraction method to find out the binary equivalent. Since for now we do not know the binary equivalent, I'm going to use the question mark. To start with, what you need to do is you need to write all the place values of 2. So we start from 2 to the power 0, which is 1. I'm going to write directly. You may convert it as well while writing. So then 1, 2, 4, 8, 16, 32, 64 and 128. So this is what you get. The Denary number you have got is 142 minus 128. Of course it's possible. So I'm going to just use another row to write the bits over here. So when it's possible, you're going to write 1, and at the same time you need to calculate the difference. So 12 minus 8 gives you 4, 3 minus 2 gives you 1, 14. Now we are going to take this 14 over here and try and see if you can subtract 64. No, it's not possible. So you're going to write 0. 14 minus 32 possible? No, 0. 14 minus 16, is it possible? No, 0. 14 minus 8. Yes, it's possible. So you're going to write the bit 1. At the same time, take the difference, which is 6. Now take this new difference over here. 6 minus 4. It's possible. Yes. And take the difference, which is 2. Now you take the new difference. So 2 minus 2 is possible. Yes. And 1. Now you take this over here. 0 minus 1, it's possible. No. So you're going to write the 0. Now this reflects the statement. It says involves successive subtraction of powers of 2 until the value 0 is reached. Okay, now that you have got these bits together, let's check the answer. So what we're going to do is convert the binary back to denary and check the answer. So I do hope you remember from before, you need to multiply the respective values and add them together. So this means 128 times 1. So 128 plus, we are going to ignore the values which are 0. Take the next value, which is 8 plus 4 and plus 2. So let's see what we get. 8 and 8, 16, and 4, 20, 22. We get 2, 2, 2 is 4 and 1. So we have got the equivalent, which is the denary. So basically to write the answer, you should write like 1, the 3 zeros together, the triple 1, 0, and this is the binary equivalent for 142, which is in denary. I hope it's clear. We do use the division method or the subtraction method depending upon which one you're having expertise with, but mostly it's the division method which seems to be more accurate as compared to the subtraction method. Let's try one more example. So I'm going to do the same denary to binary. Let's take another number, let's say 69. So the question is 69 from denary to binary. What's it? Using the subtraction method. Use subtraction method. Let's get started. So we are going to write the place values of 2. So you need to see how far you have to go. 69. So let's get started. 1, 2, 4, 8, 16, 32, 64 and 128. I'm sure by now you have got this memorized and it's very clear. 69 is greater than 64, so we do not need 128, so we can ignore that straight away. So we need to find out 69 minus 64. So 69 minus 64. Is it possible? Yes. So you're going to write 1 and take the difference. The difference is 5. Now we take this over here. 5 minus 32. No. So it's 0. 5 minus 16. No. 0. 5 minus 8. No. 0. And then we get 5 minus 4. Yes, it's possible. So you're going to write the bit 1. At the same time, take the remainder. Now this new remainder is going to be used over here. So we have got 1. 1 minus 2. Is it possible? No. So you're going to write 0. 1 minus 1. It's possible. Yes. And it gives you 0. Since it's possible, you're going to write 1. Now this is the binary bit we have got. So let's convert this back into the denary and check it out. So 64 times 1 gives you 64 plus 4 times 1 is 4 plus 1. So this is straight away 4 and 4, 8 plus 1, 9 and 69. So let's put it together. We have got 1 triple 0, 1 0 1 from binary back to the 69 in a denary. I do hope now it's clear how to convert the denary to binary using the subtraction method.